JavaScript data structures for girls. Or, don't let your trees bite you. Unlike algorithms, which are interesting calculations, like converting Celsius to Fahrenheit, data structures kind of just sit there, waiting to hold your data. You can send a data structure somewhere, or just save it to disk. A data structure is like a harness that holds structured data in some nifty and sometimes really nifty way. Trees are the most fanciful data structures, and all you have to do to make one is say, branch has a value property and a list of children, to which you can add other branches. So we can build an infinitely sized tree by just nesting branches within branches. You just need like 2 lines of code, one for the value, which could be an object and is kind of the point of having a branch. It holds something. For example, a person that has an email address, or an animal with a type and a name and such. And then a list of other branches. So it is a recursive, nested data structure. Branches within branches within branches. Your file system has a tree data structure. It holds files, which are forbidden to have children, and folders, which you are free to nest and pickle with files. But as you learn programming and make your own trees, for example, for a virtual world that has a lobby in some building, the building in a world divided by areas that have monsters and very likely more trees, or as it is in my case, you have an application that has reusable modules and scenes, where scenes can contain windows and pipes that connect windows together, there is a danger that your tree will attack you with complexity and all that nested recursive thinking. Because as beautiful as trees are, they are, let's face it, infinitely complex. There are no rules, and even with a pretty graph, it is hard to visualize everything, for tracking bugs and memory leaks for one. And unfortunately, and this should come as somewhat of a shock, you should always be mindful of multiple users editing your tree. Even if you don't plan on having multiple users, you will find it useful to open multiple tabs or windows, or even have a split pane in your application. Moreover, you may wish to save your tree to a database, which is based on rows and tables. Very useful for dealing with multiple users, as everything just kind of collapses into fields and simple squares or cells, similar to a spreadsheet, so that you are no longer in a confusing recursive data structure environment. But now that means you need to collapse your tree, your beautiful nested data structure, to a flat grid. In my case, I only get 2 columns, key name and value, which is what you get in a web browser storage object that you too may be working with. Now, this is not necessarily worse than something like a spreadsheet, because it is really easy to make. It's really easy to visualize. It's just like our person object from above, which has a key named email and then a value that is probably the email address. In a spreadsheet, you start naming columns, and that is messy. Not all of your stuff will have the same columns, so it's gonna get complicated. You will need multiple things with different columns, think worksheets, and you back yourself into a world of complexity again. And, you don't define your columns in the tree, so you should not define your columns in your data storage. Trees are very fluid, and naming or defining columns is very rigid. So having two columns, key and value, is bad, but it won't bite you as much as having to sit there trying to come up with column names for things that don't actually have column names. Which brings us to the point of this text, pretty much. How do you store something as magnificent and recursive as an extremely useful tree in something as bitey and primitive as a key value table? To clarify, key and value are our two columns, and to add a record, you create a new row that inherits the two columns, and that's all you get. Let's start by giving ourselves a nice break and call our root by ID of root, R-O-O-T. And you have a root folder in your file system as well. It also has a special name, so we're good on this. And now let's store a root.children key with a string of 3 letters, A, B, and C, separated by spaces as value. And just to be thorough, let's give our A child a proper name, Alice. So we will also create a new key called A.name with the value of Alice. So we now have 2 entries in our key value table, root.children with the value of A, B, C, and A.name with the value of Alice. And now we already have a tree of 4 nodes encoded in a very flat and very primitive key value table. Root.children means that there is a root node with children, and the children are A, B, C, and then A.name means that A has a name property, which is Alice. Pretty cool, huh? We know of the root node just by convention. And we can look up the root.children property, which will hold ABC by just knowing that every node has a children property. And yeah, we kind of make up a key name. So we need to have these well-structured names. So root, which is the ID of the root node, then .children is a pretty good way of storing the children property of the root. We can all agree on root.children or ID.children holding the children. Really cool. Kind of simple, but that's what programming is at the lower levels. As you convert this back to a tree, you can look up A name, B name, and C name during object instantiation, and your A child will become named Alice. You can leave the other nodes unnamed, or print a warning that B and C require names. Lastly, the browser storage object, or in my case, the web extension storage object, will trigger a change event when you give B the name of Bob in, for example, the 3rd browser window. So now you can subscribe to the storage object, a very common feature, as you build up your tree from the key value store, and have all your tree nodes listen to their properties. B, for example, would listen to the changes of the key b.name. And now, because you have tree branches listening for their names, all of your user interface gadgets listening to b.name would get the Bob update. Now, technically, the gadget that made the change would not get an event, but you may not be working with a web extension that somewhat guarantees that. You may be working with a WebSocket connection to a database, or server push events that broadcast changes into the browser. So it's always a good idea to flatten things out and say everything gets the update, and then you deal with that. So you have to check if the changes need to be made, compare new versus old, etc., etc. Sometimes you may be able to swap your storage engines if you strategize ahead of time well. So you could switch from web extension storage or browser storage to just a database on the server. One leading social network was actually using an SQL database as a key value storage. So this is the same scenario. Now, this concludes the main part of this text. We now have a beautiful idea of trees being just nested branches and a way of collapsing them into a simple key value store. Just use the ID and then .name or .children, and then you will always know to look up that field. And it's the root node that keeps track of all the IDs that you descend down as you try to figure out your tree structure. But there is one more magnificent thing in the realm of dealing with data that updates. That thing is called signals. And any chance I get, I have to tell you about it because it is life-changing. Signals are reactive variables. They announce themselves when they change. Perfect for this kind of thing where data changes left and right. All they have is .value that you can read from and assign to, and a .subscribe that accepts a function that gets executed when a signal value actually changes. And the .subscribe returns a function that, when executed, unsubscribes your subscription. Very convenient. So now, when you use a signal in place of .name, you will have to use a .value. So if you want to set the name of bnode, you have to say b.name.value. This way, we make room for saying b.name.subscribe and putting in that function, which would send information into your user interface. Very cool. Now, signals are not stupid. They are actually well balanced, tiny and really cool little machines that have a wisdom about them. If you get the same value, if you try to say that b.name.value equals Bob again, a signal will do nothing. It will just ignore. It will stay silent. So we already solved the problem of checking if a value had changed. For example, when receiving a message from the server. Did it change? It doesn't matter. The signal will ignore the same value if it receives it twice. Second of all, if you want to print tree node names in your browser window, for example, as a window caption, or maybe a caption to a little icon in a test file system that you are making, it does nothing on null or undefined. So you are not going to bother your user interface until b.name.value receives some new value, or that initial bob. Until then, your user interface update function will not be triggered. So your user interface components just say b.name.subscribe and specify a function that updates a folder name, for example. Until then, the folder label just displays blank or unnamed or whatever you designed for it to say prior to receiving a name. So you would say function input data folder label dot inner text equals input data, and you just leave it alone. It's the tiniest function in the world. You just leave it alone. It will set the name when the time is right. Whoa. So a signal just takes care of everything. You don't need to check for things. You don't need to worry about it. You just set it and forget it. A signal is like a tiny little machine that soaks up a layer of complexity and then levels things out for you so that you don't have to worry about simple things. You can very easily listen for the changes and make automatic updates when the time is right and move on. One more thing, for those of you who want to implement a signal in your program. When you set a signal value externally through your application by editing B folder's label in your fancy UI, that new name, Bob, should first set the signal value. So you would say b.name.value equals Bob, and that will assign the word Bob into your label. Previously, that was only in an input box, usually. And then immediately, in the same breath, you must then update the key value store. This is called an optimistic update. You are optimistic about the value Bob being stored in the database. So optimistic that you already updated the signal. And you should revert on key value store failure, which is easy with signals. If you get an error, you can just erase the signal value and print the error on the screen. But you must do optimistic updates because otherwise your UI will lag, especially if you are communicating with a server. So you don't really have a choice. And the signal just takes care of it for you. Boom. Optimistic updates for free. Now, setting the key value store or database may then send a notification back. That's kind of the point. But it will be ignored in your source signal, as the update will be what you just set. So there is no setting the label the second time. Very efficient. Your signal just does nothing. Issues no notifications to subscribers, nothing. When the value is the same, it does nothing, and if you have some messy logic, it also prevents an infinite loop, where the value set here propagates there and then goes back to the database, and the database again notifies you. You're allowed to keep your logic simple. Your signals will guard against these types of loops. Now, it takes care of the loop scenario in the source signal where you already set the value, but your all other windows or instances of your program where B's name is still undefined, all those signals will cheerfully and finally, and most importantly, automatically set B's name signal to Bob, and then announce the change to all the subscribers, which will update the labels. It will update the UI magically in all of the browser windows that need to synchronize with what you just did, making you a very powerful programmer indeed. I think it's really important to talk about signals or reactive variables in general. It's important to think about them, and I think we should all be using them in our programs, no matter if they are big or tiny.